Hello everyone, welcome to this presentation on the sum pair closest to target. In this presentation, we will learn how to find the pair of elements in an array whose sum is closest to a given target. Let's dive in. Our task is simple. Given an array of integers and a target number, we need to find two elements a and b in the array such that their sum is closest to the target. The pair must be returned in sorted order. If multiple pairs meet the same condition, we return the one with the maximum absolute difference. If no valid pair exists, we return an empty array. To solve this problem, we will follow a structured approach. First, we sort the array, then we will apply the two-pointer technique, tracking the closest sum as we go. Our goal is to return the pair with the smallest sum difference or the one with the largest absolute difference if there's a tie. Let's break down the two-pointer technique. We start with two pointers, one at the beginning of the array and one at the end. By comparing the sum of the elements at these pointers, we move the pointers inward depending on whether the sum is too small or too large, bringing us closer to the target. It's important to handle edge cases. If no valid pair is found, we return an empty array. Also, we ensure that the pair is returned in sorted order as required by the problem statement. Let's look at the code implementation. First, we include the necessary libraries, IOStream for input and output, vector for the array, algorithm for sorting, and CMath for absolute value calculations. Next, we define the function closest pair sum, which takes the array and the target as input. The first step inside the function is to sort the array, making it easier to apply the two-pointer technique. We initialize two pointers left and right, which point to the first and last elements of the array, respectively. We also initialize variables to track the closest sum, the minimum difference, and the result pair. Now, inside the while loop, we calculate the sum of the elements at the two pointers. We also compute the absolute difference between this sum and the target. If the current sum is closer to the target or has a larger absolute difference compared to the previous best, we update our closest pair and the minimum difference. Next, we move the pointers. If the current sum is less than the target, we move the left pointer to the right to increase the sum. If the sum is too large, we move the right pointer to the left. If the sum equals the target, we can break out of the loop since we have found the closest pair. After exiting the loop, we check if a valid pair was found. If the result array is empty, we return an empty array. Otherwise, we return the closest pair. In the main function, we define an example array and a target value. We then call our closest pair sum function and display the result to the user. Let's walk through an example. Suppose the array is 1, 3, 4, 7, 10 and the target is 15. We will use the two-pointer technique to find the closest pair step by step. Initialize the sum of 1 and 10 is Initially the sum of 1 and 10 is 11. We move the left pointer to 3. After several steps, we find that the closest pair is 4, 10 with a sum of 14, which is the closest to 15. Now let's discuss the time complexity. Sorting the array takes n log n time and the two-pointer traversal takes n time. Therefore, the overall complexity is n log n, where n is the size of the array. In conclusion, the two-pointer approach is an efficient way to find the pair whose sum is closest to the target. Sorting the array ensures we can use this technique effectively, and with a time complexity of n log n, this solution is suitable for even large input arrays. Thank you for your attention. If you have any questions or would like to discuss any part of the presentation further, feel free to ask now.